For more than a century, human flight has depended on one powerful technology, the combustion engine. From the earliest passenger flights to today's massive international airliners, aircraft have relied on jet fuel to power their engines and carry people across the world. Every day, thousands of planes take off from airports around the globe, connecting cities, countries, and continents in a matter of hours. But while aviation has transformed how we travel, it also has a cost. Modern aircraft burn large amounts of fuel, releasing carbon dioxide and other gases into the atmosphere. Today, aviation contributes roughly 2 to 3% of global carbon emissions. As air travel continues to grow, scientists and engineers are searching for cleaner alternatives. One of the most promising ideas is electric flight. Electric airplanes, powered by electricity instead of fuel, could change the future of aviation. But how do electric planes work? Why are they important? And can they really replace the aircraft we use today? To understand this, we first need to understand how electric aircraft are different. Traditional airplanes run on jet engines that burn aviation fuel. Inside these engines, fuel is ignited and expelled at high speed, creating the thrust that pushes the aircraft forward. Electric airplanes work in a completely different way. Instead of burning fuel, they use electric motors powered by batteries. These motors spin propellers or fans, which generate thrust and move the aircraft through the air. Electric motors are not only simpler than jet engines, they are also extremely efficient. While conventional jet engines convert only about 30 to 40% of fuel energy into useful motion, electric motors can convert close to 90% of their energy into propulsion. This means electric aircraft waste far less energy during flight. But efficiency is only one reason why electric planes are gaining attention. The biggest advantage of electric aviation is environmental impact. Because electric aircraft do not burn fuel during flight, they produce no direct carbon emissions. If the electricity used to charge their batteries comes from renewable sources like solar, wind, or hydroelectric power, the environmental benefits could be enormous. Electric aircraft could help reduce the carbon footprint of air travel and make aviation far more sustainable. Another important advantage is noise. Jet engines are extremely loud. Anyone who has lived near an airport knows the sound of aircraft taking off and landing. Electric motors, however, operate much more quietly. This could significantly reduce noise pollution around airports and make air travel less disruptive for nearby communities. Electric planes could also reduce operating costs for airlines. Electric motors have far fewer moving parts than combustion engines. With fewer components to wear out or fail, maintenance could become simpler and cheaper. Electricity itself is often cheaper than aviation fuel, which could eventually lead to lower operating expenses for airlines. Despite these advantages, electric aircraft still face major challenges. To understand these challenges, it helps to compare electric planes with conventional aircraft.
To understand these challenges, it helps to compare electric planes with conventional aircraft. The biggest difference lies in energy storage. Jet fuel is incredibly energy dense. 1 kilogram of jet fuel contains about 12,000 watt-hours of energy. Modern lithium-ion batteries, the type used in electric vehicles and aircraft prototypes, store only about 250 to 300 watt-hours per kilogram. In other words, jet fuel holds more than 40 times the energy of batteries for the same weight. For airplanes, where every kilogram matters, this difference is critical. Another advantage of traditional airplanes is that they become lighter during flight. As fuel burns, the aircraft gradually loses weight, which improves efficiency and range. Electric airplanes do not have this benefit. Their batteries remain the same weight from takeoff to landing. Because of these limitations, the range of electric aircraft is currently much shorter than that of conventional airplanes. Large passenger jets like the Boeing 737 or Airbus A320 can fly thousands of kilometers without stopping. They connect cities across entire continents. Electric aircraft today are far more limited. Many experimental electric planes can fly only a few hundred kilometers. Some smaller aircraft designed for pilot training can remain in the air for about 50 minutes to 1 hour before needing to recharge. This makes electric planes ideal for short flights, but not yet suitable for long-distance travel. Even so, electric aviation is already becoming a reality. In 2020, a small aircraft called the Pipistrel Velis Electro became the first fully electric airplane to receive certification for commercial use. This two-seat aircraft is mainly used for training new pilots. It demonstrates that electric aviation is not just a concept, but a working technology. Several aerospace companies and startups are now developing larger electric aircraft designed for short regional routes. Some of these planes aim to carry between 9 and 19 passengers. There are also entirely new types of electric aircraft being developed, known as electric vertical takeoff and landing vehicles, or eVTOLs. These aircraft are designed to operate like flying taxis, transporting passengers across cities quickly and quietly. However, despite these developments, there are still no fully electric commercial airliners capable of carrying hundreds of passengers on long-haul flights. The main reason is simple: batteries. To power a large passenger jet with today's battery technology would require enormous battery packs. These batteries would be so heavy that the aircraft would struggle to take off, let alone fly long distances. Until battery technology improves dramatically, electric aircraft will likely remain limited to smaller planes and shorter routes. Scientists and engineers around the world are working to overcome this challenge. New battery designs, advanced materials, and hybrid propulsion systems are being explored. Some researchers are also investigating hydrogen-powered aircraft as another possible solution for cleaner aviation. The future of flight may not rely on a single technology, but on a combination of new innovations working together. Electric planes may first transform short-distance travel, connecting nearby cities and remote regions with quieter, cleaner flights. Over time, as technology advances, the dream of large electric airliners may eventually become possible. For now, the massive jets that cross our skies still depend on the same powerful fuel that has driven aviation for decades. But change is coming. The next revolution in aviation may not be powered by fire and fuel. It may be powered by electricity. And the journey toward that future has already begun.